Hello. You okay? Should see the desktop and you should hear me. Can you hear me? Is the desktop seem okay? Is
Yeah,
every
yeah.
okay? Great. Thank you. Okay, let me kind of set things up. Okay, they'll have people entering. Okay, getting up there. Okay, so for today, got a couple things to point out. First exam is coming up. On the syllabus, it actually said the exam was supposed to be this week, but since I forgot to mention it. I'm going to postpone it because I want to give you time to be ready for it. So on the syllabus, it actually said it would be this Thursday, but I'll make it a week from Thursday. Okay. So instead of this coming Thursday, which is only 2 days from now, it'll be a week from Thursday on October 1st. Okay. So I forgot to mention it last week, move it up 1 week. So there's a bunch of review problems here to help you get a sense of what to study, how to study for it. So let me open this. Here's what the exam's going to cover. We've been using two books, and it's going to cover chapters 1 through 5 from the Think Java book. Okay, 5 is what we're going to start with today. So we're going to be working on that this week. Okay, so 1 through 5 in the Think Java book, and these sections from these 3 chapters in the other book. Okay, so we've worked with two books, and it's the first few chapters of this book and the first 3 chapters, the first 2.5 chapters of this book. Okay, and then here's a list of topics that we've covered. Okay, so this is a list of topics, and then here's a bunch of review problems that are similar to kind of problems you'd expect to have on the exam. Well, on the exam, you're not going to write large chunks of code. The exam is to make sure that you understand the ideas we've talked about and that you could read code. So on the exam, you'll be asked to read bits of code like this or like this and say what they do or find a mistake in them. And you'll be asked to write maybe 1 or 2 lines of code. You see, some of these problems ask you to write a line or two of code. Others ask you to explain what a little bit of code does. Okay, so for example, here you have to know what's the difference between those 2 lines of code? What do those 2 lines of code do? What do these various pieces of code compute? Okay, like here's a problem where I want you to fill in those 3 variables. Okay, so you read this part, and then the problem asks you to fill in what should be A, what should be B, and what should be C. Okay, here's another one where you have to figure in what's A and what's B. Okay, so these are the kind of problems that could be on exam. You have to read code, explain code, and write a little bit of code. Okay, and there's about 20 problems here, and I haven't finished this. I'm gonna actually edit this. I might drop a couple problems and add a couple problems, but you could definitely start on these. Uh, Starting with problem 14, this is the stuff we haven't talked about yet. So these last 5 problems, we haven't talked about them yet. That's the stuff on if statements and Booleans. So that's what we're going to be talking about this week. Okay, and then but all these other problems are things that we've talked about. So you could start thinking about these problems as a way to study. If you can solve these problems, then then you don't then you're ready for the exam. If you don't understand one of these problems, you should go back and read a section. If you're not sure what to read, you can always send me an email. I can tell you, like, if you have a question about a particular problem, I can tell you what section you probably should read to remind yourself about what that problem is about. Okay, and also if you have questions about the problem, I can answer questions about these problems too. Okay, now these problems are review problems, so they're not the exam. So these are problems that you can work on with other people. You can look them up. You can ask me questions about them. I'm not going to give you the answer. Some people have asked me before if I'll give out an answer sheet to this, and the answer is no. I don't want people memorizing these, and I want you to solve these. So I'm not going to give an answer sheet to these problems. Though if you solve one and you want to know if you got the right answer, you could send it to me and I'll tell you whether you got the right answer or not. So I'll answer any question you have about these problems. I'll tell you if you have the right answer. And then I'll tell you if you have a mistake. So but I won't just give an answer key to these problems. Okay. So, but you can talk with other people about them. You can ask me questions about them. You've got a week and a half to work with these and use these as a guide to figure out if you're understanding things or not. If you can solve these pretty quickly, then you know that you've got that material down. If there's a problem that you have trouble with, then you need to figure out where in the book or what examples we did in class would help clear up what you don't understand. Okay. So again, most of this is questions about the ideas. You're not going to be asked to write 20 lines of code on the exam. Your exam will be, can you read the code and tell me what it means and what it does? Can you add a little bit to the code? Like, can you add the definitions of the variables here? Okay. Or another example, one farther down, fill in the blank. Can you figure out what goes there, there, and there to make the code work? So kind of a fill in the blank kind of problem. Okay. Like here, you have to read this and find a mistake in it. The code doesn't do quite what it's supposed to do, so you have to think about what could be wrong with that. So read code and answer questions about code is what this is about. Okay. Now let me see. Now the test will be what it's going to be is that on the test day will be October 1st. After class, the test, you can download the test from Brightspace after class, and it'll be due at midnight that evening. So you have the whole evening to work on the test. Instead of it being a time test in class, it'll be a time test, but after class, and you'll do it you'll download the exam. You'll probably the best thing to do is download it, print it, write out your answers on exam, and then use your camera or a scanner, use your phone camera or a scanner to scan your test back into the computer and you'll upload it back to Brightspace. So you'll download the blank exam from Brightspace and you'll upload your finished exam back to Brightspace. And if you don't have a scanner, you can, cell phones will scan if you have the pages of the exam, there are apps you can get for your cell phone that will essentially convert your exam back to a PDF. So that what I don't want you to do, and I talk about, is don't send me photographs of your pages. That's a nightmare. I really can't work with that. It becomes a nightmare. But there are apps that you can download from your phone. Like there's one called Adobe Scan, works real well. You take, like if you have a 5-page exam, you take 5 pictures, but then it gives you a PDF document. It gives you a nice PDF document with the pictures as pages of the PDF document. So you just use that app when you're taking your pictures. So there's Adobe Scan is a good one. There's a bunch of others. Your phone might even have one on it. Okay. Adobe Scan works pretty well. It may not be the best, but it works well enough. Okay. If anybody knows of one they think is better, be willing to know. I played with Adobe Scan. It seems to work pretty well. Okay. If somebody knows what they think is a really good scanning app, now you have to get one. Adobe Scan works on both iPhones and Androids. But let's see. I think Microsoft has a scanning app that's part of their suite. I don't think they call it Microsoft Scan, but let's see. I think, yeah, maybe this is Windows Scan. Yeah. Mm-hmm. Okay. Yeah. And these are free apps. Okay. The key is you snap a couple pictures, 1 picture per page, and the app turns it into a single PDF document that you can upload back to Brightspace. And then I can print your exams, or I can read your exams much better. If you send pictures of your pages, it becomes a nightmare to manage it because there's so many students. I end up with hundreds and hundreds of files, and it becomes impossible to work with. So it needs to be one PDF document for each student, the pages of your exam in one PDF document. Okay? And if you have questions about how to do that, let me know. You can ask. I can send you. You can download these things and just try them out. That's what I did. I put the Adobe Scan. I downloaded it to try it out, and it worked pretty well. I opened a book up and just took pictures of like 5 pages in the book, and it turned into a real readable. It turned into a real readable document. If you're willing to sit there and photograph the pages of a book, you could have a book as a PDF document pretty fast that way. Okay, so it worked pretty. It worked pretty well. You just flip through the pages of your document and just take a picture of each page, kind of like they're showing here, and it puts the pages in the PDF for you. Okay, so the exam will be next Thursday. It'll be available at the end of class, and you'll have to like midnight to finish the exam. And you'll have to download it, you'll have to print it out, then you can sit down and take it, spend time taking it. Then when you're done, you'll have to photograph it, put it back, photograph it, scan it, and then upload your PDF back into Brightspace. Anybody got any questions? Okay. Anybody have any questions? Okay. All right. So, and then, like I say, if you have questions about the review problems, let me know. Talk to people about them, look them up, ask me questions about the review questions. Start looking at the review questions. Okay. All right. Now, another thing here that's a little bit new is we're going to start talking about what are called if statements and logic. And here are some practice problems involving them on a website called CodingBat. CodingBat is a website that lets you practice solving coding problems. So here's what it looks like. Okay. This is a problem on CodingBat. What they do is they describe the problem here. They give you examples of how the problem should take input and output. They give you a place for you to type your code for the answer. Then you click go, and I'll show you in a minute that when you click go, it tests your code. Okay. Now, this is a warm-up problem. Warm-up problems, they show you the solution. Okay. Well, here's what the problem is. The problem is given a string and an integer. So you're going to write this function called missing char. And it's going to take as an argument a string. So it takes a string parameter, and it's going to take in an integer. So it takes in an integer parameter. Okay. And given this string and this integer, you're supposed to return. This is what this says. This says you're returning a new string that has that character removed from the string. Okay. Now, remember, we said that strings. Well, actually, I'm sorry. These problems aren't if-then statements. These problems are string problems. I made a mistake. I said a minute ago that these problems here are actually review problems for strings, not for if statements. So these problems are similar to the homework exercise that you're working on, assignment 3. These are string problems, not if-then problems, not Boolean logic problems. Okay, so remember now, letters in a string have an index. The K is index 0. The I is index 1. So you're supposed to remove the character with index 1 from kitten. Here you're supposed to remove the character with index 0 from kitten, so the output would have the K removed. Here you're supposed to remove character 4. Well, character 4 would be the 5th character, okay, and that's the E. So there's what you return. Okay, so they tell you in words what these problems should do. They always give you examples of if you call the function with such and such input, here's what the output should be. So they give you some examples of what the output should be given certain inputs. Then they give you a place to type your code. Now here, they let you see the solution. Okay, so I'm going to pretend that I'm solving this problem. So here's one line of the solution, and then here's the 2 more lines of the solution. Okay, so here's the solution, 3 lines of code. Okay, now I copied that from them, but here, now suppose I wrote this code. After I finished writing the code, I click Go. Go will compile, run, and it'll call your function with a whole bunch of test cases and tell you whether you got them right or wrong. Okay, so right away it did the 3 examples here. It did those first. Then it did a whole bunch of other examples. Notice that I got everything right. It told me what was the expected output, what my output actually was, and whether that was okay. Now, what happens if I goof up? Now, here's what it looks like when your code is wrong. So here, the expected output was this, but my output was this. And they try to use color to show you what they think, where the wrong part is, and I got that wrong. Okay. Now, if I play around with this, oh, let me just delete this line here. Okay, now here's a more typical case. I got some things right and some things wrong. So when the input was this, I was supposed to have that output, but I had that output. On the other hand, when the input was this, I was supposed to have that output, and I got it right. Okay. Now, most of the time, this is what you'll see. You'll type some code, and you'll have some things wrong and some things right. And you have to use the information about the wrong things to figure out what your code still isn't doing right. Notice that it's not like a math problem where you get partial credit. Getting some inputs right and some inputs wrong is not partial credit. That means your code isn't doing the right thing yet. You don't have the logic of the code correct yet. So you have to get all the tests passed to be really doing things right. Okay. So what you do is you think about what they said here, you think about your code, and you look at the mistakes you got, and you try to figure out, what did I do wrong? I didn't get that output when the input was this? Why did I not get that? Why did I get that output when I was supposed to get that output? And so you use the wrong answers to try to guide you to figure out what you did wrong. Now, this is really good practice in programming. This is very, very much what honest to goodness programming really works like. In the real world of programming, companies divide the work up into two people. One person writes the code, and another person figures out what the test should be. And then the person who wrote the code has to check it against the test that the person who wrote the test did. And in real jobs, this is how almost everything is done. You have a description of something that needs to be written. One person says, one person's job is to write the test that will help you know when the code works properly. Another person writes the code. Now, sometimes the same person does both, but they still need to have a set of tests and the code that passes the test. But it's real common in companies that there are people who are great at writing tests, and they get the job of writing the tests, and there's people who write the code. Okay, so many companies divide it up into two things. People who write the tests and people who write the code. But everybody works this way. Your code isn't done until you pass all the tests. Now, if I go back to the correct solution, okay, not this one yet. I'll show you in a minute another one. Sometimes they actually, well, let's see, let's try another problem.
Professor,
Yeah.
what does return mean?
That's the answer that the function gives back. Let's see. We probably did do enough examples of that. So let's see. I'm going to the chapter about methods. So it's chapter 4. Let's see, where is it? See this thing here? We probably didn't say enough about it. Return values. It's like in math, when you plug a number into the cosine function, it gives you back the cosine of that number. That's the return value, what it gives you back. Okay, right? So you do that a lot in math. We haven't done enough examples of that in here. So we'll go back and we'll do that some more. But that was it's very much like in algebra and calculus with math functions. When you say you give the function a number and it gives you back a new number, it returns to you a new number. Okay, so the examples are here: absolute value, sine. The sine of an angle gives you back some number. The absolute value of a number is some other number. Okay, so that's called the return value. Okay, now over here, what you're supposed to do is supposed to give back. Let's see. So here, see, this function took in kitten and the number 1. It's supposed to return that string with the first character removed. In this case, it took in kitten with the number 0. So it's supposed to return or give as output or give back that string with the 0th letter removed. Okay, so this is what the function calculated. It took in this input and it did a calculation, like the squaring function or the logarithm function or the sine function. It did a calculation and it gave that answer. Now the calculation was these lines of code here. Those lines of code did the calculation and it then returned this answer here. Okay, so it's the idea that a function takes in an input and gives you back an answer that is what it computed from that input. This is the name of the function. The name of the function tells you what the function does. So this thing's called missing char. It will remove a character from an input string. So you give it the string, you tell it which character to remove, and this thing gives back to you what you asked it to do, the string with that character removed. Everything on CodingBat is written as a function that takes some input and gives you back an answer. Everything is done that way. Everything is written as, every problem is described as some method that takes something as input and gives you back some kind of answer. Then over here, when they run it, they show you they ran your function with that input. This is what was expected to get back. This is what you actually did get back. In this case, got the right one. Okay. This style of coding, besides being, like I say, what companies do a lot, it's actually how they're now interviewing people. Companies now make use of websites like CodingBat as a way to test people when they interview them. In fact, like I show you, one that they use a lot is, this is a website that companies use all the time for testing people. This is a website very much like CodingBat. The big difference between this one and this one is this one's free and this one's meant for freshman classes. So the problems are at the level of an introductory course. This one, companies pay money to use this website. They pay money to be able to use this website to interview people. And the problems are much harder. The problems are the kind of problems that companies would use when they're hiring somebody. So this company is in business to serve other companies that want a way to interview people. And this company lets developers practice on their website for free. So as a developer, you could sign up with them and practice on their website all you want. But if you're a company and you want to use this website for interviewing purposes, you have to pay them. You have to pay them to set up interviews. So the interviews are actually set up on this website. And this has got nothing to do with the epidemic that's going on right now. This is right now, companies are interviewing remotely, but even when companies were interviewing in person, they still use this website. They'd have people sit at a desk with their browser just like this open, and they would point at a problem on this website, and they would have a person solve the problem, like here in front. Yeah, they watch you solve the problem. Yeah, when if this was a problem in a job interview, you would sit there and read this, and then you'd have to think real fast, and you'd have to start typing code, and they would watch you as you're typing code, and they want to see how you fix problems as you go along. You'll type some code. Nobody expects you to get the right answer right away. They'll give you a certain amount of time, and you just write code, check it, see what you did wrong, go back, make changes. And it's kind of high pressure, but that's how companies pretty much, that's one step of almost everybody's interviewing these days. And Coding Bat's nice because it's a way for you to get used to that style of programming. First of all, it's a good way to practice. Yeah, here there's no pressure, there's no time limit or anything, but it's a very good way to practice. And they have hundreds of problems up on this website. They're lumped into groups. Okay, so like these are hard string problems. So these are the problems, and you can just click on anyone, and there's the problem. There's a description. There's some examples. That should be enough for you to get started. If you click go, well, I didn't even have any code in there. So okay, look, I just typed return 0 and I passed 4 tests. That's not worth any partial credit. I'm just answering 0 all the time. No matter what the input is, I'm saying 0. But that actually was the right answer 4 times. Okay? Yeah. So, but notice that you just start working by, you type some code, and like in this case, returning 0 gave me a sense of what they were going to test for. Okay? So, now, here's an example. Here you can see what they're testing for. But see then this one down here? They're keeping some tests secret. Okay? They don't want you to see all of the tests. So if you pass all these, you might still fail this one, but then all you know is that you failed, and it's up to you to figure out what went wrong. So they're giving you a lot of examples here, but if somehow you manage to pass all these, there might be some other tests that you don't pass, and this would just say fail, and you don't even know if it's 1 more test, 10 more tests, 100 more tests, and they won't tell you. And that's also over here, it'd be the same thing. You will see some of the tests, but there'll almost always be a little checkbox that just says other tests, where you're not seeing what the tests are. And if you fail that one, you just have to figure out, what are you doing wrong? You have to go back and read here, figure out what is it that you're missing from your code where you're still failing tests. Okay, all right. So Coding Bat is a very nice way to get started with these kinds of practice problems. This is geared towards a first course in Java. All these problems can be done after a first course in Java. The string 1 you could do right now. Okay, string 3 you can't do yet. String 2 you can't do yet. String warm up in string 1 you could do, and we're about to do the logic ones. Like after this, by the time we get to the first test, you'll be able to do logic 1. And then after the test, we'll learn a little bit more, and you could start doing the second string 2 problems. These are a little bit harder string problems. They require a loop, which we haven't talked about yet. Okay, notice that these have no loops. We haven't talked about loops yet. These start using if statements, which we're about to start talking about. Okay, so the problems are actually in the order of what most freshman classes teach. So as the semester goes along, you can work your way farther and farther through these problems. So they're kind of in the order of what we teach the material. Over here, the problems are just hard. They're used for interviews. So the problems for the most part are hard, but like I say, they let developers practice on them. After you've taken the freshman and sophomore level classes, if you're a computer science major, after the sophomore level classes, you can go to this website and start doing the easier problems here. They do give, I think they do rank the problems in terms of easier and harder for the developers. So I think if you go to the developer part of the website, I think they do separate them from easier and harder. But I know that after like the sophomore level computer science classes, you could start probably working on problems on this website, because they do use this website for interviewing interns. So those would be easier problems than if they were interviewing people for experienced jobs. So they interview for internships, and companies use this website for both internships and real jobs. So I think they have problems ranging from probably close to this level. They may even have problems at this level if they're interviewing people for internships, all the way up to very difficult problems that are testing people who supposedly have years of programming experience. Okay, but this style of working, somebody just says, here's a problem, here's some examples, now write the code. That's a good way to practice, and then keep modifying your code until you get the right answer. Okay, so I gave you, I pointed you at 3 problems here. 2 of them are warm-up problems. They actually have the answer. 2 of them are warm-up problems. If you really want it to, you can just see the answer. And then this one's not a warm-up problem, so there's no answer button. And then if you want, you can go up to string 1, and you could try other of these. These are not the warm-up ones. None of these have answers. You could try any of them if you want. I don't think they go from easy to hard here. I think these are all uniformly about the same. I don't think they're meant to be in an order. Like, I don't think this one's supposed to be any really harder than this one. Okay, so I'm pretty sure these are just in a kind of a random order. Okay, so you could, but if you weren't, you could always start with the first ones. Yeah, if nothing else, you can, if they are in order of difficulty, it would be easy. You can just start with the first one. Or if you want, you could start with the last one and work your way back. If you find the last one easy, you can try. But I don't think they're ranked. I don't think they're ordered by difficulty. I don't think they are. But it might be that maybe some of these are harder than others of these. It might be that some of these last ones are a little bit harder. But I know that most of these are about the same. When I looked at them, I just randomly looked at a bunch of them. They all seemed about the same level of difficulty to me. Okay. All right, so I gave you 3 to start, and then as the semester goes along, I'll assign you practice problems from Coding Bat, because they're very good ways to practice thinking about Java and thinking about programming. Oh, one last thing. They give you stuff here to read. Like, if you had no clue what any of this was about, they have information here about strings and substring. So, they actually have help that are more or less about the kind of ideas that are in these problems. So that's another nice thing that they do, is that they point you in the direction of some examples that would be relevant to this. Now, in this case, none of this is relevant to this problem. This stuff is from much later in the course. So these first few things here are relevant to this problem here. Okay, so string, substring. So if you click on this, it's a little video. That's the guy who created this website. He's a teacher at Stanford University. So this website was created by people at Stanford University, and he's one of the teachers who made this. Okay, so they do give you a little bit of help. They do have some information here, though. Right now, I can tell for this problem, only these first few things would be useful. So all this other stuff is not relevant to this particular problem at all. Okay. All right. Now let's start talking about this stuff over here. Okay, we want to introduce a new topic. Let me close these windows. Okay, so we're going to talk about something called conditionals and logic. Okay, what we want is for programs to be able to ask, is something true or false? We want programs to be able to take branches. We want programs to say, if the character picked up a rock or didn't pick up a rock, if the character turned left or if a character turned right. The program should have ways of having logic in one case and logic in a different case. So we need to be able to, first of all, ask a question that's either true or false. So that's, here's an example of that. If I ask, is X, this is supposed to be read, is X equal to Y? Okay, so X holds some number and Y holds some number, and this asks, are the numbers equal? Okay, now they don't have any code here. So let me open up the Java visualizer and just show you that you can, what that would mean. So let me go to the Java visualizer. Okay. So let me create an integer x, and let me create another integer y. And now I can ask, is x equal to y? Okay. Now that thing is going to be either true or false. But if I want to, well, let me print it. So I can see the answer. Now I know which one that is. 23 is not equal to 12. So this is a false statement. X equal to Y is false. Oh, what did I forget? Oh, I forgot the equal sign here. Okay. So it printed false for me. Now, I know if I step through this, yeah, I created a variable X holding 23. I created a variable Y holding 12. That's one of the things you need to know for the exam. You have to, one of the things I'll ask on the exam is to draw these pictures. If you see that code, I would ask you, what does the memory diagram look like for that code? And the memory diagram is this part here of the Java visualizer. That's one thing you need to know for the exam, is because we're doing this a lot, and it's how we think about code. This holds the number 3 in that variable. This holds the number 12 in that variable. So that's what it looks like. This asks, is the number in X equal to the number in Y? And the answer was false. Okay. Now, on the other hand, 12 plus 11. Okay. Now, 12 plus 11 adds up to 23. So now what's in X and what's in Y, that will be a true statement. And Java will print out, see, so it calculated 12 plus 11 and got 23, so 23 is in Y. So now Java will say true. Okay, so we have this ability now to ask a question. Is something true or false? I can ask that exact same question in kind of a funny way. I can reverse this and say, is it true that X is not Y? This gets a little bit tricky. Right now I'm asking, is it true that X is not Y? Well, it's false that X is not Y, because X and Y are the same now. So X not equal to Y is false, because X is Y. Java lets me ask these questions in a couple different ways. See, it printed false. It is false that X is not equal to Y, because they in fact are the same number. Okay. On the other hand, if I go back here, okay, X is not equal to Y. That's now true. It's now true that X is not equal to Y. Okay, so it printed out true. Okay, so we now have a way of asking in Java questions. Now let me do a different kind of question. String X equal hello. Okay. All right. Now let's see. Is X dot length, okay, that gives me the length of X. Is X dot length equal to Y? Okay, so I've got a string and I've got a number. And I'm curious to know if my string has that length. Maybe this is important in a program. Maybe I needed somebody to type something that was at least 12 characters long. You know, so, or maybe, for example, a good example would be, suppose this is a phone number. Phone numbers are 10 digits long. Okay, so if my string is holding a phone number, I might be interested in knowing, is it the right length? Okay, so is it true that the length of that string is equal to what y is? Okay, so I can ask all kinds of questions. I can have a way of asking, see, this was true. That was 10 digits in that string, which is, if it was supposed to be a phone number, that would be what I want. Okay, on the other hand, if somebody wrote the phone number this way, I can't ask that question too naively. That still looks like a phone number. Now it's false. Now that might tell me that the phone number is written a different way. We'll see what we would ask these questions for, but Java lets us ask questions like this. What is the length of a string a certain number or not? Okay, let me do another example. I could have two strings. And I could have okay. And I could ask, are they the same length? Do these two strings have the same number of characters in them? Okay, so compute the length of that string, compute the length of that string, and now ask, are they the same? Okay, we know what did I do wrong? Oh, I forgot to change that to string. Okay, that was fault. They weren't the same length. But I can ask a more interesting thing. Which is a longer string? Like I can ask, is the length of X less than the length of Y? Which is a fancy way of saying, is Y a longer string or not? Is Y longer than X? Okay. Notice that got true because it's true that Y has more characters in it than X did. Okay. Now, what we're playing with here are what the book calls relational operators. They're the things you learned about them in math. They let you ask about the relationship between two numbers. Are the two numbers equal or not equal? Is the number on the left smaller than the one on the right? Well, is the number on the left bigger than the one on the right? Is the one on the left smaller than the one on the right? Is the number on the left greater than or equal to the one on the right? Is the number on the left less than or equal to the one on the right? These are called the relational operators. Okay, they ask for a relationship between two numbers. Okay, so I've just done a bunch of examples of asking a question using relational operators. Okay, now the interesting thing is, how do we use this information? Like, suppose here, I don't really just want to know if one string is shorter than the other. Suppose I want to print the string that's longer. Okay, so I've got two strings, and my idea is not to print out which, I want to actually print the string that's the longer one. So here's what I'm going to do. I'm going to ask a question, okay? And the syntax of this is I write if, and then a pair of parentheses. And inside the parentheses, I put my question. So I'm going to put the question, is X shorter than Y? Okay. Now this is called an if statement. The way it works is I say if, and then I put a question that's either got a true answer or a false answer. Suppose I want to print the longer string. Okay. So what would I do here? Okay. Well, there's two cases here. If this thing is true, then Y is the longer string. So if this is true, I know that Y is longer than X. So I'm going to print Y. If see, now I have another word I can put here, else. Else is, what happens if this is false? Well, if this is false, I really want to print X, because that means that if this is false, then X is the longer string. Okay, so This is what we call an if-else statement. I've got my two strings, and now here I write my if statement. I want to ask which one, I want to figure out which one's longer because I want to print out the longer one. I could ask it a lot of different ways. Like I could change this less than symbol to a greater than symbol, but then I have to change what I did over here. Okay, oh, let's see, and then this should be X here. The way I'm asking now, I'm asking, is X shorter than Y? Okay, if that's true, that's this part here. If that's true, then Y is the longer one, so I print it. But if this guy is false, then I go down here to the else part. I skip over this one and go to this one, but now I know that I should print the X one. So I'm printing the longer of these two strings. Now let's visualize it. I create my two strings. Now I ask this question. Okay. Now I'm only going to do 7 or 9. If this thing is true, I'll do line 7. If this thing is false, I'll do line 9. I don't actually do line 8. Line 8 just separates these two. You never execute line 8. You execute line 6 because you have to check which one of these, check if this is true or false. If it's true, do this. If it's false, do this. Okay, now, okay, this was true, so I'm going to print out group. Now notice I went from line 7 to the end of the program, skipped over 8 and 9. Okay, now let me go up here and rechange this. Okay, now I made X the longer string. I'm still going to print, now this code here is still going to do the same thing. It will print the longer string. Okay, there's X, there's Y. Okay, if X is less than, if the length of X is less than the length of Y. Okay, well, the length of X is a much larger number than the length of Y. So this is a false statement. So I skip over this and go to this. So you'll see now, I'm going to go from line 6 to line 9. See, I went from 6 to 9 because what was in here was false. Okay, and now I print out the longer string. Notice I've got a little bit of logic that no matter what you put in here, I always print the longer of them. Okay, now there's a little bit of a funny thing here. What if they're the same length? Which one will I print? Now, if they're the same length, maybe I don't care which one I print. You know, I want to print the longer one. If they're the same length, you know, they're both the longer one. Now, think about which one will I print, X or Y, if they're the same length? If they're the same length, is this true or false?
False.
It's false if they're the same length because I put a strictly less than here. So if they're the same length, who do I print?
X.
The first one, okay? Now, if I change this to less than or equal to, it doesn't change the logic. It's still going to print the longer string, but now it'd print Y if they're the same length. That would still make the program correct. This would print the longer string, and this will print the longer string, but they're not quite the same. This will print X when they're the same length, and this will print Y when they're the same length. But they're both going to print the longer string. Okay, let's check it here. Let's do this one. Now I have the two strings the same length. Okay. X and Y have the same length. You can see that there's the same number of characters. This guy's going to turn out to be false. Okay, so that thing will be false. So we'll jump to line 9 and we print out X. Okay, so when they're the same length, this one prints out X. On the other hand, if I go back here and change this to an equal sign here, less than or equal, it's still printing the longer name, the longer string. It's always printing the longer string. It still has that logic, but now it'll print out. Now, is the length of X less than or equal to the length of Y? Well, yeah, they're equal in this case. So now it prints out y. Okay, so it printed out the y1 in that case. Okay. Right. So the logic can be tricky. You know, you can have two correct ways. Like the problem here would be always print out the longer string out of x and y. But if you always, but that leaves ambiguous what to do when you have equal length strings. You have to print one of them, and you could end up either printing one or the other. Both of these answers would be correct. This one prints out one of them, and this one prints out the other in the case where they have equal length. Okay. No, so now one thing that's important is even though these relational operators are about numbers, notice over here I'm asking questions about strings. But since I'm asking about the length of the string, I can use the thing about numbers. So notice that this is a relationship about numbers, but given this string, I can compute the length of the string, so I can ask a question about numbers about strings. So I can print out the longer string by asking a question about numbers. Okay? All right, so these are the two main ideas. What we call a Boolean expression, something that asks a question that's either true or false. We can put a Boolean expression in an if statement, and then our program can branch to either the true case or the false case. And this is a huge part of programming. These branching statements are incredibly important. They're one of the three fundamental pieces of what makes programming. We'll see that there's really only, there's like four fundamental pieces of what makes programming. Methods, which we've seen already, variables, which we've seen already, if statements, and loops. With methods, variables, if statements, and loops, you can write any program in the world, okay? You're really just those four things that make up programming. Now, there's going to be a lot more things. We have a lot more things to make it easier to write programs, but you can actually write any program in the world by combining variables with methods and if statements and the thing we'll call loops. You can write. So this is a huge part of programming, along with the variables and the methods. Okay. Okay. Now, so we've just talked about the relational operator and if-else statement. Okay. Now, relational operators are not the only things that can ask a question, but they're the easiest ones for us to use. Okay. For a while, we'll pretty much always ask a question using a relational operator. Okay. They're real easy to use for asking yes or no or true or false questions. We'll see as we go along, there are other ways of asking true and false questions besides the relational operators. But for now, we'll stick with these. Okay, and we stick them in an if statement. If this is true, you do that part. If it's false, you do that part. Okay, and notice that there's only a relational operator can only get, there's no in between, true or false. Okay, so there's only two alternatives. If true, do this, if otherwise, do that. Now, here's something that's interesting. You don't have to have this part. You can just say if, ask a question, and then do something. You don't have to have the else part. It's not that common. Whenever you use an if, 9 times out of 10, it should be paired with an else. Occasionally, it's okay to have an if that's not paired with an else, but it's actually, a lot of people don't think it should ever be done. There's one style of programming that says every if must be paired with an else. Java doesn't enforce a rule like that. Some languages do. Some languages do not allow this, an if unpaired with an else. What you're saying is, if this is true, do this, and if this is false, just skip down, just skip to the next line of code. Okay, if it's true, do this. If it's false, just skip to the next line of code. Here, you're saying, if this is true, here's exactly what you should do. And if it's false, here's exactly what you should do. You give code for both alternatives. Code for the true alternative and code for the false alternative. Many companies require every if statement to have a companion else statement. They say, if you tell me what to do when this is true, you should tell me what to do when it's false also. But Java doesn't enforce that rule. You can just say, if it's true, do this. If it's false, just continue on. Just skip over this. And we'll see every once in a while this is useful sometimes. See, this is saying if you've got a positive number, do this. Otherwise, just don't do anything. You know, well, I shouldn't say don't do anything. Go to the next line of code. What you do then is you go to whatever comes after this in the next line of code in the program. So you're not saying what to do in the false case. In the false case, you just continue on with whatever comes left. Okay. So occasionally we have ifs without an else. Most of the time we pair them together. You tell me, you ask a question. There's what you're asking. Is this true or false? What to do when it's true? What to do when it's false? And then after you've done one or the other, then you go to the next part of the program. You know, after you've done either this or this, then you go to the next part of the program. Okay. Now, if I go over here, what if I do, here's something I might want to say. I'm just going to print a little message. If X is less than Y, I want to print the longer string is, and then the string. Okay. This is broken. I've broken a rule in Java. If I visualize this, first of all, I got a compiler error. Okay. I have two lines of code between the if and the else. When you have two lines of code between the if and the else, you have to lump them together with braces. Now, if you have only one line of code, you don't have to put the braces. Now, if you look over here, he was putting the braces even when there was only one line of code. And that's actually the right way to write code. You should always put the braces. I was not putting the braces a minute ago, just kind of to show you that I didn't have to. But the general rule is, even if you have only one line of code, if you only have one line of code between the if and the else, you should still put braces. But over here, as soon as I put two lines of code there, I needed to have a pair of braces. So that's saying that I want to do everything that's between these braces when this is the longer one. So now I go over here, and what's going to happen is, when this is true, I'm going to go to line 8. Oh, I'm sorry. Well, I have mixed. Let me go back in. Okay, make X the longer one. Okay. 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 X is the longer one. So I wanted X to be the shorter one. Okay. Okay. X, the length of X is less than the length of Y. X is the shorter one. So then I go down here and I start doing everything that's between the braces. So do line 8. The longer string is, then print out the longer string. Then when I'm done, I leave. Okay. Now, what if I wanted to have a similar kind of thing down here? Suppose I want two lines of code there. Well, if I'm now, this is dangerous here. Remember when I had two lines of code here and I didn't have the braces? I got an error message. No error message. Okay. Now watch what happens. This is actually okay. Watch what happens. Oh, I didn't change. I want to do this part now. So now I want to make hello the longer of them. Okay. Okay, the length of x is not less than the length of y. So this is false, so I'm going to jump down to here. So I'm going to jump from line 6 to line 12. Okay, all right. Now, oh, that didn't show what I wanted to show. Oh, this these two lines of code are not lumped together like these two were. This is actually, I'll say, how can I show you that these were not lumped together? They were not lumped together like these two were. What happened was the else clause was only that line of code there. That line of code there is not part of the if else. It's actually should be, it really is a line of code by itself. The rule in Java is if you don't have a brace after the else, there's only one line there. Okay. When I put two lines there and indent them like that, Java doesn't treat this line as a group with that line. This line is actually by itself because there's no brace. So this line is the only one tied to the else. I'm trying to think of a logical way to show you that these are not lumped together. It's hard to come up with an example to show you that these two are not lumped together. Offhand, I'm not thinking. See, these two, if I didn't lump them together with a brace, then Java complained that there was a line tied to this if, then this line was by itself actually, but then this else was all by itself. It wasn't paired with that if anymore. This line here broke, this line here turned this if into a single thing if. See, it turned this into a single thing by itself. So this one was really here now. If only has that part there, and this else is all by himself and he's wrong. So the visualizer complains about the else without an if. Okay? Because this line wasn't the problem. This line is no longer part of the if and it's out here. To make it part of the if, I have to put braces around it. So I put brace there, brace there. Now here, without the braces, this line here belongs to the else, but this line just sits over here by itself. But then logically, it follows that line. Oh, I know how to show you that this. Oh, now I know how to show you. Okay. Now I remember. Go here and make hello shorter. Yeah. Okay. Make hello shorter. Now we see our program's all messed up. Okay. It looks to me like these are lumped together, and they are by the braces. It looks like to me like these are lumped together, but they're not really lumped together. So watch what happens. Okay. X is the shorter one. So I'm going to do line 8. Now I do line 8. Now I do line 9. But look where I jumped to. It looks like I jumped where?
Printing X.
Pardon me?
Printing X.
Yeah, but what's wrong with that? Why would I not want to jump to printing X? In my logic, where did line 13 belong in my logic?
To else.
To else. You know, when this was false, you're supposed to do those two lines of code. But I'm doing that line of code when this guy is true, because he's actually not part of the else. So now you can see that See, I printed out hello anyway. I wasn't supposed to print out hello when the longer string is goodbye, because this is not really inside the else. It really is by itself like that. Now, part of what I'm showing you is how important indentation is. When I indent the code like that, it looks like I'm telling you something about the logic, but I'm actually indenting the program incorrectly. The indentation is like that. So what this code does is it creates this variable, does this if. If the if is true, does those two lines. If the if is false, it does that line. And then after the if, which is those lines, then it does line 13. Line 13 comes after the if. Even if I indent it like this, line 13 is not part of the else. How do I make line 13 part of the else? What do I do to make this guy paired with this guy? How do I pair lines 12 and 13 together?
With a bracket.
With a pair, with a bracket, a set of brackets. There. Now they're paired together. Now watch what happens when I run it. I will, okay, now x is less than y. So I'm supposed to go from line 6 to line 8. Okay, line 8, line 9. Now I'm done with the if part. I skip over the else part. So now I'm not going to go to line 14. I'm just going to go straight to the end of the program. See, now this guy's truly lumped in with this one. Okay, now notice how subtle this stuff is. Let's go back to a poorly written program. Somebody writes this. They think there's two pieces in the else clause and two lines in the if part. Okay? If it's true, do those two lines. If it's false, do those two lines. The trouble is, you'll get an error message about this mistake, but you won't get an error message about this mistake. And it's quirky that you get an error message about this mistake and you don't get an error message about this mistake. They could have fixed this in Java by requiring you to always put braces after an if statement. And the designers of Java didn't make that requirement. They probably should have. It was probably a mistake on their part, because this bug shows up actually pretty often in Java. People goof up the brace. You know, one reason why they would write this code, this is Python. In Python, you don't put braces. You use indentation. This is actually correct Python. So if you spend half your life writing Python and then you switch to Java, you can accidentally write correct Python when you're in Java. In Python, there are no braces. You just say if, then you indent, that's the first part. Then you say else, then you indent, and you indent, that's the else part. And then when you're done with the else part, you go back to like here. Okay, so this line is not in the else part because it's indented back out here. Now that's Python, but it's real easy to get this stuff goofed up. In Python, the indentation is what we say the block of code. In Java, the block of code is what you put braces around. Okay, so that made 8 and 9 a block. That made 8 and 9 a block, but 12 and 13 are not a block yet. Okay. Right now, 12 is a block by itself because I didn't put braces. So 12 is the block by itself. And 13 is just like 14. It comes after the else. Very dangerous. It was a bad decision of the Java people to design it this way. But they designed it this way because the C programming language was designed this way. The C programming language didn't require the braces. Okay, and the C programming language was designed that way because back then that was back in the 60s. They didn't think it was that important. They didn't want to force you to type braces if you didn't have to type braces. Partly it was because back then computer memory was so expensive that saving a pair of braces was useful to them. You didn't have to store those braces. Okay, so if you go back to the C language in the 60s and 70s, they did not require the brace in this case. So Java did it the way C did it, but that was a mistake. So like this brace is not required because there's only one line here. This brace is not required because there's only one line here. But then down here, oh, see, here's where he's showing you the problem. It looks like this is a block, but it's not a block, okay? Only this is in the if statement. This one's not part of the if statement. It should be indented out here, okay? So you have to be careful of the blocks. Indentation can look like a block in Java, but it isn't. Then the Python programmers said the braces are superfluous. What you really want are just the indentations. So the Python people got rid of the braces, but then they force you to use the indentation. Notice that in Java, you can actually write the following. Okay, that's all goofed up Java. Java doesn't care. Indentation actually means nothing to Java. And that's really bad style. In your homework assignments, we're going to start taking off points if you don't indent properly, because nobody can read your code if you don't indent properly. Even though it's not required in Java, your code is a mess. You know, this is just an unreadable mess. You know, it's, you know, you have a really super hard time. If I do, like some people do this, they just put everything along the left-hand margin. Okay, that's a valid Java program. It'll, well, actually, oh no, it's not because of that one. So I can, I need to put a brace there and a brace there to make it a Java program. Notice that this editor wants to fight with me. It wants to indent. It's been trained to do indentation. But see, oh, what did I do wrong? Oh. There, see, Java doesn't care about the indentation. Okay, but you can't read that. You start losing, you have almost no sense of what the logic is anymore. Unindented code is really hard to read. Okay, and I can make it even worse. I can just do this. You know, it's still valid Java. Yeah. So Java doesn't care about indentation, but all programmers do. Nobody's going to accept this kind of code from, yeah. You really do need to indent things carefully so that people can read your code. Python forces you to indent. Okay, this code would never execute in Python. You would just get all kinds of error messages because there is no indentation in it. So the Python would reject it. Java doesn't care, officially doesn't care about indentation, which makes things, which gives you the potential to do things really poorly, especially beginning students who don't really yet understand what's important, what's not important. So you don't really know yet what should be done and what shouldn't be done. And definitely what's important is you should indent. Indentation is really, really important. Okay, so, and every time there's a brace, that means I indent inside the brace. Okay, so I indent inside the brace. I should make that brace line up with the one before it. Now I'm back to that level of indenting. Now I should be inside. But if I want to lump that one with that one, then I have to give it braces and then that one should be there, okay? And actually, none of these are indented properly because this method should have been indented. So all these should be indented one more time. Because I didn't see first there's the class, then there's the main, that's the second indentation. Then your code is actually the third indentation. Then this is the fourth indentation inside the if. So I've got 4 levels of indentation already. And then this one is over here. Okay, so notice I've got a total of 1, 2, 3, well, 1, 2, 3 indentations, 4 different levels. 1, 2, 3, 4 different levels with 3 different amounts of indentation. The indentation is real important. Okay, so we run out of time. So continue reading this section. We've just introduced the idea of it. Okay, there's the reading is, these sections are short, but read them. This is actually a very terse explanation of all this stuff. There's much more detail in this other reading from the other book. Okay, so these other reading, with the ones with that has the built-in questions, there's a lot more detail in here. So read the first book. The first book will probably leave you maybe wondering a little. I'm sorry, find the right page. This one might leave you wondering. There's not a lot of detail in here. It's really an overview. It has every fact you need to know in it, but not a whole lot of explanation. So every fact is there, but not a whole lot of explaining and examples. This one has a lot more examples and explaining. So this section explains Boolean expressions, and then the next section explains if statements. Okay, and then we'll go on the next section on if-else statements and else-if statements. We have a lot more to do here. Okay, all right. Anybody got any last question? Anybody got a question at all before we quit? Okay, so as usual, if questions come up about the homework, the program assignment, or about the review problems, please send me an email. Ask questions as soon as they come up, and come to office hours on Monday, Wednesday, or just send me an email or ask for it to meet by Zoom at some time. So if you have questions, please ask. Okay, so we'll meet again on Thursday. So I'm going to go ahead and stop sharing first. Okay, and I'll go ahead and end the meeting and see you on Thursday. Bye.